Hello everyone. So welcome back. Welcome to Launcher, and we are back here with our next session. So we have had sessions on triangles, different properties of triangles, right? Then we looked at different quadrilaterals and then regular polygons as well last time, right? Okay, so so therefore the next segment is circles, as you can see, right? So circles have their own properties, but at the same time, as you know, that questions are not isolated in geometry, and all the base concepts that we have learned with respect to the triangle geometry will obviously come relevant here as well, right? But yes, definitely circle questions require their own kind of approach. They have their own properties of angles, properties of tangents, properties of chords, how to find the areas of different portions, right? So all that we'll cover, right? Let's start. So as always, we'll look at first few previous year, and then we'll also look at some extra questions, right? So without further ado, let's start geometry circles. Okay, here we go. First one. So as in any question, you know that when figure is not given, we have to first of all sketch the figure. So let's understand the question. Let's sketch the figure. CAT 2001 question. A semicircle is drawn with AB as its diameter, right? So write a semicircle, half of a circle, right, with AB as the diameter. So yeah. Now from C, a point on AB. So AB is the diameter, and somewhere there's a point C. Let's say somewhere around here. A line perpendicular to AB is drawn, meeting the circumference of the semicircle at D. So this CD is drawn basically perpendicular to AB. Given that AC is 2 centimeters and CD is 6 centimeters, we are asked to find the area of the semicircle. Obviously, area of the semicircle will be half of pi r square, where the radius is obviously the only thing we have to find. Now, so I'll give you the mantra of circle questions. Means, like, I told you in triangles, whenever you feel stuck, always think similarity. So in circle questions, typically you have to construct the radial lines, and then the geometry concepts will start. So typically doing some further constructions is required in more general sense, but most of the times, like, radial lines are the most common things, because a circle is only comprised of a thing, which is the center and the radius, right? So by drawing the radial lines, you will then be able to relate the different concepts of geometry. In this case, so right now, till now, we have not drawn that, so let's do that. Let's say this is the center of the circle O. Join OD, because that is the only point I can see where I can join this. OD will be the radius, and OA will also be the radius. That means OC will be radius minus 2. This is 90-degree angle. So I have a right angle triangle OCD, in which R 6 and R minus 2. Pythagoras theorem should give me the value of the radius. So 6 square plus R minus 2 whole square equals R square, right? So 36 plus R square minus 4R plus 4 is R square. This goes off. I'm getting 4R to be equal to 36 plus 4, 40R is 10. So basically, if you look at this closely, this is nothing but 6, 8, 10 triplet, double of 3, 4, 5, right? So there is your answer, half pi R square. R is 10, so half pi into 100, so 50 pi. There is our answer, right? So a basic question to start with, and the moral of the story is constructing radial lines will typically lead you towards the solution, right? And more things, let's see, right? Many things to look upon in circles. Next one, recent last year question only, CAN 25s. Let's see. Two tangents drawn from a point P touch a circle with center O at points Q and R. Fine. There goes your circle. And there goes your tangents. Yeah. Pretty much. So this is point P and touching the circle with center O at points Q and R. Complete the figure, draw the radial lines without saying. This is 90 degree and this is also because basic thing, the radial line is always perpendicular to the tangent and the point of contact. Points A and B lie now the story starts from here. I mean, this is the figure, but now further he's saying points A and B lie on PQ and PR respectively, such that AB is also a tangent to the same circle. Now he has not mentioned anything specific about how and where these A and B are oriented. So it is any random tangent, right? And then angle AOB is given and we have to find angle APB. Well, draw some tangent somewhere, I mean passing in any which way. This is A and B, right? And now angle AOB is given. So obviously you need to join AO and OB as well, so that this angle is 50. Now from there you have to reach to angle APB. How will we do that? Now looking at this figure again just in isolation as it stands, you might figure out, okay, what to do. I mean, how is angle AOB linked to the further part of the story? Because the thing is that we don't know much about A and B, so it might feel we don't know much over here. But again, I told you the key, draw the radial line. Now you might think I have already drawn OA, OB, now what? You see, the way you have joined OQ and OR, the points of tangencies of the two tangents PQ and PR, you have not done the same as of yet for AB. AB is also tangent, it is also touching the circle at some point, and you have not joined the center of the circle to that point of tangency. Let's say some point A, B, C, X, whatever, right? So now the thing is that this is also 90 degree, this is also 90 degree. Now you see triangle geometry comes into picture. Look at the triangles OAX and OAQ. OX is equal to OQ is equal to radius. AX is equal to AQ is equal to tangent. Length of the tangent from an external point is always equal. And OA is common. These triangles are SSS congruent. All the three sides are the same. They are congruent. Hence, this angle must match with this angle. If this angle is alpha, this angle is also alpha. Triangle congruence. Two pairs of congruent triangles are there. The way OXA and OQA are congruent, likewise OXB and ORB are also. Because the same thing, OX is equal to OR is equal to radius, BX is equal to BR is equal to tangent, and BO is common. So that's the thing that we had to crack. Now you can see what has happened is the whole of AOB angle is nothing but alpha plus beta. I don't know alpha, I don't know beta. I'm not saying I know them. But all I'm saying is that I just need that much, because now focus on this quadrilateral that you have, obtained by the original tangents PQ and PR, right? So in that quadrilateral, these two angles are 90 each, PQOR. So sum of angles of a quadrilateral is 360. So these two are 90 each. So therefore the other two angles, these two adding up to 180, the other two must also add up to 180. Let me draw this separately just so that you are perfectly clear what I'm talking of. I'm talking of this PQOR, right? In which we know that this is 90, we know this is 90, and we have figured out this is twice of alpha plus beta. right? Angle QOR is 2 alpha plus 2 beta. So since we know alpha plus beta to be 50, so we know this angle to be 100, and hence that is 80 to complete the sum of the angles of the quadrilateral, right? So very brilliant question, I would say, where this observation is required about these congruent pair of triangles, right? So there goes the question where whatever and wherever these A and B are, regardless of that, since you know AOB to be 50, you know QR to be 100, you know QPR, which is the same as AOB also to be 80, right? So that's the way. Let's see what more we have, right? Lots to gather the way to deal with questions. Let's see next. Here we go. CAT 2020 question, and this is again a brilliant question. Let's see. Let C be a circle of radius 5 meters having center at O. Let's draw a circle. The radius of the circle is 5 meters. Center is O. Nice. Let PQ be a chord of C. Okay. That passes through points A and B, where A is located 4 meters north of O. North of O, 4 meters. So that's 80% of the radius, right? And B is located 3 meters east of O. So at that 60% down the line, right? So I get a sense of these points, something like, let's say this is A, right? This is OA is 4 north, and OE is east, and that's 3, right? OB. You will find the length of PQ. PQ is the chord obtained by joining A and B and extending them. So something like that. All right, so how do we do that? Let me just make this more clear. Right. Yeah, so there is your A and there is your B. Okay, so what do? We know this is 4, we know this is 3, we know the circle's radius is 5. Well, the circle's radius will come into picture only when I join O to the end points of the chord. So that is very clear that I need to draw that I need to draw that radial line. But the point is that how to make use of this 4 and 3 with regards to finding the length of this chord. So you see, more things have to be done. Just drawing this won't help. I mean, obviously you have to draw this, but to begin with, how to make sense of this 3, 4, 5 triangle? Obviously, this is a right angle triangle because this is north, this is east, so they are 90-degree. So that completes a 3, 4, 5 triangle. AB length is 5. Now, you see, this is PQ. The basic thing of chord, the most basic property, the perpendicular drawn from the center of a circle to a chord bisects the chord. The first property that you learn about chords. You need to do one more thing, and that was drop this altitude. As soon as you do that, let's say this is point N, O N is the altitude. You know NQ is half of PQ. And you can try to find NQ because in this right angle triangle ONQ, you can try to find ON. That is the length of the altitude drawn to the hypotenuse of a right angle triangle, which is well defined. And OQ is 5. I think we are on our way, right? So as far as ON is concerned, remember we have discussed this. It comes to be basically AB upon C, right? By equating the area of the triangle in two ways. That area of the triangle is half into 4 into 3, as well as 5 half into 5 into this height h. So this height h comes to be 3 into 4 by 5. AB by C. I've given you this formula, right? So therefore that is coming to be 12 by 5 or 2.4 centimeters. Since we have to find the value in decimals, because nearest to. So it's definitely some square root thing. We have to find the approximate value. So I'll put it in decimal form 2.4 and then proceed. And I'll say that NQ, which happens to be half of what I'm trying to find, half of PQ. So NQ will be under root of OQ square minus ON square, which means under root of 5 square minus 2.4 square. So we need to do this calculation. That's all. And that is our answer. We have to calculate this. So, right. So half of PQ is under root 25 minus 24 square is 576. So this is 5.76. So PQ is twice of root 19.24. 25 minus 5.76. Take this to inside because I have to calculate this, right? I won't want to calculate 19.24 square root separately and double that. I would just want to do whole under root of, take to inside. So 4 times of this, 19 4 is 76, 0.24 4 is 96. Almost, we are very close to root 77, almost. And now go to the options. Clearly, this is somewhere between 8 square and 9 square, 64 to 81, and much closer to 81. So much closer to 9. So 8.8 should be the required length over here of the length of the chord PQ, right? So therefore, very nicely, I would say, constructed question, where a whole story about northeast, right? And to begin with, you would think that, okay, how do I relate this triangle OAB with respect to the chord PQ? So the whole point was to join the radial line and then drop the altitude and then solve that triangle, right? So therefore, I think the again and again we are coming across this thing that some more figures require us to do little bit more with it, right? थोड़ा सा कुछ और बनाना पड़ता है, कुछ और जोड़ना पड़ता है, तब बात बनती है, right? So that's the theme. Okay, perfect. चलिए next one. Okay, so in this question, some kind of area has to be formed. We have to find some kind of area. Let's see. Draw the figure. Let's see. In a triangle ABC, AB equals AC equals 8, an isosceles triangle. A circle drawn with BC as diameter passes through A. So what I get in my mind is there is an isosceles triangle whose base is the diameter of the circle passing through the opposite vertex. Means this is a triangle inscribed in a semicircle effectively, right? So draw that figure, right? There is a circle and there is an isosceles triangle inscribed in it with one of the with its base as the diameter of the semicircle. So this is your BC and AB equals AC. So this is right angle triangle for sure. Why? Because we know that the angle inscribed in a semicircle is always 90 degree, and moreover it is right angle isosceles triangle. So this angle A is 90 because, right, because of the semicircle, and these two are 45 45 each of them are equal to 8. Now, so another circle is drawn now. This is the first circle. Another circle is drawn with center at A. You see the center of this circle is here, the midpoint of BC. Call it some point O, right? Now, so now we need to draw one more circle with center at A passing through B and C. Means the radius is AB. What is the radius of this circle? OB. We need to find that. The radius of that circle is AB. Now, AB is obviously more than OB, right? I can also tell you the length. AB is 8, AC is 8. So BC is 8 root 2. So this OB is 4 root 2. So the radius of this circle is 4 root 2, whereas the radius of the circle that we are now going to draw is 8. So it is a larger circle with AB as the radius. So it will go something like that. Yeah. Let me do one thing. Let me draw this with different ink so that we can clearly distinguish that circle from this one. And so there is another circle like that. Yeah. Something like that. Yeah. We'll do with that. Yeah. Okay, so what we have to find, we have to find the area of the overlapping region between the two circles. Overlapping common region between the two circles. You can see one part above BC, which is the semicircle itself, that is common obviously, plus another segment below BC, right? So clearly the required area is the sum of the areas of these two segments, right? So the required area is the area of simply the whole this of the semicircle, involving ABC triangle. You can say OBAC, that whole semicircle, plus the segment, which is, let's say this OBXC. Yeah. So I hope you're getting what I'm trying to say. You have to add that semicircle and the segment below, right? Both are segments. The first segment is the whole of semicircle. Okay, so semicircle is area is half pi r square. Now, what is the radius of this OABC? Obviously, it's OB, which is 4 root 2. So half pi and square of 4 root 2, right? Plus this. Now, the area of the segment will be, always the area of a segment can only be obtained by taking the difference of the area of the sector involving that minus the area of the triangle. Means ABXC sector minus triangle ABC. But you know one thing is very beautiful in this question. If you just find the first part, this is for 16 into 2 by 2, 16 pi. Look at the options. You can easily eliminate. Why? 16 pi is ruled out. Area is more than 16 pi. 32 pi is also ruled out because clearly this area is much smaller than 16 pi. You can visually see that, and it is impossible for this area to also be equal to 16 pi. Clearly you can rule this out. 16 pi minus 16, not possible. It has to be more than 16 pi. Only this can be correct. So actually, even with geometry and finding some things like here, there we are finding area, you can just eliminate, right? First part only, you can eliminate the options. It must be that option A. But yeah, so I can finish this for you, that definitely this will match because segment OBXC will be sector ABXC, which will be now, so that will be a quarter circle because this is 90 degrees, so it's a 1/4 of a circle, right? So 1/4 of pi r square, and our radius is here as 8, so half pi into 8 square minus the area of the triangle ABC, which is simply half into 8 into 8. So doing that gives us the required value, because this is 64 by 4, 16 pi, and this is minus 64 by 2, 32. So yeah, that is 32 pi minus 32. That is what we said, right? So always remember, area of a segment can only be obtained as taking the difference of the area of the segment involving area of the sector involving that segment minus the area of the triangle uh, you know contained in that sector, right? Okay, so I hope that this is making sense. Can we move to the next one? Let's see. Now another recent year question. Some ratios are there and some ratio is asked. Wow, let's see what is there. A quadrilateral ABCD is inscribed in a circle. Fine, let's do that. Let's do that. Now, this question comes with very, very, very useful result. I mean, an important property that you should always know. In case you don't know, in this question, what you will come to know, please do remember that it's a very useful property. So, again, let me put a different color over there. Something like, yeah, so I've done some zigzag. Okay, so ABCD is inscribed in a circle such that this is not a trapezium, by the way, huh? Don't think like that. लग रहा है but ऐसा नहीं है. कुछ भी है, हमें बस ये ratios पता है. AB is to CD is 2:1. So if this is 2x, then this is x over there. Because there's another ratio, so I want to clearly demarcate the two ratios. This is 2 is to 1, so 2x and x, and BC is to AD is 5 is to 4. So if this is 5y, then this is 4y. And you need to now join the two diagonals AC and BD, and they are given to be intersecting at the point E. Perfect. And you are asked to find AE is to CE. So that is your figure. Now, okay, so let's do this now. So the very important property, whenever you have a inscribed quadrilateral, both the pairs of opposite triangles are similar. देखिए फिर से हम ट्राइंगल की सिमिलरिटी पर आ रहे हैं. सिमिलैरिटी से ही ये क्वेश्चन होगा और बहुत बढ़िया तरीके से होगा. कैसे? पहले समझो कि सिमिलैरिटी किस तरीके से है. हाउ? Why? So, see, the property of inscribed angle. In any circle, any arc always subtends the same angle on the same side of the circle. So, look at arc CD. It is subtending angle DAC and also angle DBC on the same side of the circle. So, these two angles must be the same. Same for arc AB. So, ADB angle should be equal to ACB angle, and therefore you can see these triangles AED and CEB are similar. But wait, that is not all. ये जो AED और CEB में बात है वही दूसरे पेयर ऑफ ऑपोजिट ट्राइंगल्स में भी होगी. क्योंकि आर्क AD को क्यों भूल जाएंगे आप? आर्क AD जो एंगल DCA सबटेंड कर रही है और वही उसी तरफ DBA एंगल सबटेंड कर रही है, ये दोनों एंगल्स बराबर होने चाहिए. सिमिलरली आर्क BC मेकिंग एंगल CDB and CAB must be the same. So ये दोनों ट्राइंगल्स क्यों पीछे रह जाएंगे? ये दोनों भी सिमिलर हैं. CED is similar to AEB. Now, why did I write both the similarities? Because आपको निकालना है AE is to CE. आप अगर किसी एक ट्राइंगल में सिमिलरिटी लगाएंगे तो आपका आंसर नहीं आएगा. देख लीजिए. अच्छा, आपको लगेगा कि चलो ADE और CEB में ही काम कर लेते हैं, बट ध्यान से देखिए, अगर आप सिमिलरिटी लगाते भी हैं राइट इन दोनों ट्राइंगल्स में, मैं लिख भी देता हूं ADE इज सिमिलर टू BCE. सो ये जो एंगल है इसके ऑपोजिट आपको DE दिख रहा है. नहीं, मुझे D नहीं चाहिए, मुझे AE चाहिए. मुझे ये दूसरे वाले एंगल D के ऑपोजिट AE दिख रहा है. तो मैं क्या कहूंगा? AE रेशो. अब कॉरेस्पॉन्डिंग एंगल कौन सा है? उधर से है ये एंगल C, उसके ऑपोजिट क्या है? BE है. पर मुझे BE तो चाहिए नहीं था, बट मुझे लिखना पड़ेगा. और क्या करूं भाई? AE और BE ही रिलेट हो रहे हैं. इज द सेम एज मुझे तो ये वाले रेशियोज पता ना, AD और BC. तो ये थर्ड एंगल बचा है उनके ऑपोजिट 4y अपॉन 5y, तो 4:5 की रेशियो है ये. आई हैव टू होल्ड ऑन टू दिस थॉट एंड देन मूव टू द अदर पेयर ऑफ ट्राइंगल्स. राइट, यहां से AE इज टू BE आया है. अब ये इस तरफ आपका जो ये वाले ट्राइंगल्स सिमिलर हैं, CED which is similar to BEA. See, I am writing the similarity in the same order. मैं ऑर्डर का ध्यान रख रहा हूँ कि सेम एंगल्स जो हैं उस ऑर्डर में मैं सिमिलरिटी कह रहा हूँ, CED एंड BEA. तो अब मुझे क्या चाहिए? यहाँ पर AE के साथ मुझे तो CE चाहिए था, तो मैं C पर फोकस करूंगा. इधर से ये एंगल B के ऑपोजिट ये है CE. एक सेकेंड, हम किसकी बात कर रहे हैं? हम जस्ट 1 सेकेंड, हम इन दोनों ट्राइंगल्स की बात कर रहे हैं. CED है ना? सॉरी, इधर देखना था मुझे इस ट्राइंगल में. तो C जो है ये डबल डॉट वाले एंगल के ऑपोजिट है C, इधर डबल डॉट के ऑपोजिट BE है. कोरिलेशन आ गया, उधर भी BE और इधर भी BE. तो डबल डॉट वाले एंगल के ऑपोजिट इधर CE है, इधर BE है. शुड बी इक्वल टू एंगल E के ऑपोजिट इधर X और इधर 2X. सो 1/2. Hence, dividing these gives you the required ratio. Dividing these two ratios, BE will cancel. AE by CE, dividing these gives me 4/5 over 1/2. So that's 8/5. Right? That is your answer. तो क्वेश्चन थॉरली सिमिलैरिटी से ही हुआ है. ऑब्वियसली उसको ऑब्जर्व करके वो सिमिलैरिटी आई कैसे है? वो सर्कल की प्रॉपर्टी से आई है. इस सर्कल में any arc subtends the same angle anywhere on the same side of the circle. So always remember that in an inscribed quadrilateral, always the both the pairs of opposite triangles are similar. और उस सिमिलैरिटी के ऑर्डर का ध्यान रखना बहुत इंपॉर्टेंट है, क्योंकि होता क्या है, पता है क्या है, हमें लगता है अच्छा अच्छा वो अल्टरनेट एंगल जिक्र होते हैं, इसमें अल्टरनेट एंगल की प्रॉपर्टी नहीं है, इसमें दूसरे तरीके से प्रॉपर्टी है। तो एंगल किस ऑर्डर में सिमिलर है उसका ध्यान रखना बहुत जरूरी है, ठीक है। Okay, so well, we have got a lot of concepts across the breadth, but we'll do more. हम नहीं रुकेंगे और ट्राई करेंगे। लेट्स सी, कुछ और क्वेश्चंस देखते हैं बियॉन्ड PYQs। लेट्स सी, राइट, आई ब्रॉट सम क्वेश्चंस फर्स्ट। Now, okay, so there's a question with no options. I have to just figure this out. Let's see. A rectangle is inscribed in a circle. ठीक है भाई, कर लेते हैं। पहले तो सर्कल बना लेते हैं, फिर उसमें रेक्टेंगल भी इंस्क्राइब कर लेते हैं, एंड सच दैट वन ऑफ इट्स साइड्स इक्वल्स द रेडियस। So fine, let's say something like this can look like radius के around, and this should look like a longer side, right? So let's say this is equal to the radius. What is the question asking? To the nearest integer, what percentage of the circle's area is occupied by the triangle? तो कुछ मुझे लग रहा है कि कुछ इरेशनल वगैरह कुछ आ जाएगा, समथिंग विच आई हैव टू कैलकुलेट अप्रोक्सीमेटली टू द नियरेस्ट इंटीजर द परसेंटेज, राइट। तो पहले तो इसका एरिया निकालें इन टर्म्स ऑफ पाई आर स्क्वायर, राइट। सो how do we do that? Well, the obvious thing is that this is diameter. Obviously, when you inscribe the rectangle, so the diagonal of the rectangle is the diameter of the circle. So this is 2r and this is r, so therefore obviously this is being 90 degree, so that makes this as root 3r, right? So it's a 1 is to root 3 is to 2, मतलब ये 30 60 90 ट्रायंगल हो गया है। मतलब द पॉइंट इज कि दूसरी लेंथ आ गई, ये रेडियस है तो रूट 3r है, तो एरिया ऑफ देयरफॉर द रेक्टेंगल इज सिंपली लेंथ इनटू ब्रेड्थ r into root 3r square. So therefore you are required to calculate the fraction of this with respect to the area of the circle, which is simply pi r square. तो आपको ये √3/pi इसको कैलकुलेट करना है अप्रोक्सीमेटली टू द नियरेस्ट इंटीजर, राइट। Well, so √3 is approximately 1.73 and pi is 3.14. So that we have to calculate. So doing this gives you approximately, you do this, you get around 55% to the nearest integer, right? Perfect. So वेरी बेसिक क्वेश्चन, जस्ट एक रेक्टेंगल था, उसमें एक लेंथ दी थी, दूसरे कैसे निकालेंगे? फ्रॉम द कंसेप्ट दैट द डायगोनल ऑफ द रेक्टेंगल इज नथिंग बट द डायमीटर ऑफ द सर्कल, राइट। तभी तो ये 90 डिग्री है, राइट। ये 90 डिग्री है क्योंकि एंगल इंस्क्राइब्ड इन अ सेमी सर्कल इज ऑलवेज 90 डिग्री। ऑल राइट, सो दिस वाज दिस वन। और देखते हैं। Okay, so this question for the first time is giving us a figure. Now let's see. Yeah, so in the figure below, median AD is drawn, we can see, to the side BC of an equilateral triangle ABC. ठीक है, ABC is equilateral, inscribed in a circle which meets the circle. AD की बात कर रहा है, AD meets the circle at P, right? We can see that. And we can also see AB has been extended and CP has been extended and they are meeting outside the circle at Q, and we are asked to find the ratio of two lengths AP and CQ. Well, AB is the diameter of the circle, that is very simple, and CQ is some length. So what do we do? Well, in such questions, obviously you have to take something as the connecting thing, right? In the sense that when you have this triangle, so where is the I mean, either you take the radius of the circle as the common connecting thing or the side of the triangle, right? So, uh, let's first of all look at triangle. I think triangle I would take as the connecting thing over here. The reason I'm selecting that is if I take AC, the side length, as a parameter A, then I can try to find in triangle APC. I'm focusing on triangle APC. So what I'm trying to do, I'm trying to find the length AP in terms of the side length A, because I think I can find the angles of triangle APC. Well, simply we know this is going to be 30 degree, right? Because this is the line of symmetry in the equilateral triangle. वो 60 डिग्री को बाइसेक्ट करेगा. AD जो होगा वो मीडियन भी है, वो एंगल बाइसेक्टर भी है, वो परपेंडिकुलर बाइसेक्टर भी है, तो वो 30 डिग्री होगा. एंड दिस एंगल ACP इज 90 डिग्री. सो इट्स 30 60 90 ट्रायंगल. और मैंने आपको बहुत बार बोला हुआ है कि 30 60 90, 30 30 120 ये वाले ट्रायंगल्स में साइड्स का रेशियो रट लो. 30 60 90 इज 1:3:2 इज द रेशियो द साइड्स. तो AC जो है हमारा वो 60 डिग्री के ऑपोजिट है. AC जो है हमारा वो 60 डिग्री के ऑपोजिट है. तो 60 डिग्री के ऑपोजिट अगर A है, तो ये जो AP है वो 90 डिग्री के ऑपोजिट है. तो दैट शुड बी 2/√3 टाइम्स ऑफ दैट. So 2/√3 times of A, right? So therefore in triangle APC, we can say that AP is 2/√3A. Now CQ पर आना है तो एक और ट्रायंगल को देखेंगे. जिस तरह से हमने ये APC को एनालाइज कर लिया, तो अब हम ट्रायंगल AQC पर आ जाएंगे. द पॉइंट इज, मैंने आप अब समझ पा रहे होंगे कि मैंने AC को क्यों कॉमन चीज लिया, क्योंकि वो कॉमन है. वो APC और AQC में कॉमन है और मुझे CQ चाहिए. डू आई नोट द एंगल्स ऑफ ट्रायंगल AQC? यस. एंगल C तो अभी भी 90 डिग्री है ट्रायंगल AQC में, और इधर से ये पूरा का पूरा एंगल QAC पूरा 60 डिग्री है. तो अगर वो पूरा 60 है तो ये 30 डिग्री होना ही चाहिए. तो ये भी 30 60 90 हो गया. लो भाई, मजे आ गए, राइट? इजंट इट? सो इसमें 30 के ऑपोजिट A है. इसमें ट्रायंगल AQC में 30 के ऑपोजिट A है AC. तो ये जो CQ है वो तो 60 के ऑपोजिट है. तो 60 के ऑपोजिट जो होगा वो √3 टाइम्स होता है. तो दिस बिकम्स √3A. क्या? CQ. So CQ is √3A, and therefore I think we can easily take the ratio 2/√3 is to √3 is 2:3, है ना? √3 into √3 हो जाएगा. The required ratio is 2/√3A is to √3A. तो √3 into √3, that becomes 3. 2:3. Brilliant question, right? So हम कर क्या रहे हैं? हम तो ट्रायंगल ज्योमेट्री लगा रहे हैं भाई. ऐसा नो, ऑब्वियसली सर्कल है और एंगल इंस्क्राइब्ड इन सेमी सर्कल इज 90 डिग्री. वो बेसिक चीज यूज हुई है फॉर श्योर, राइट? सो आई होप यू गेटिंग द पॉइंट. ज्योमेट्री स्टेप बाय स्टेप ही आगे चलती है. बेस बनाए बिना आगे बढ़ नहीं सकते, राइट? सो बेस इज ट्रायंगल्स. Okay, so let's look at more questions. Let's see next one. Here we go. Now let's see. Here we go. Next one. Okay, so AB is a chord of a circle with center O. ठीक है भाई. Yeah, we'll do with that. AB is a chord of a circle with center O if the circumcenter of triangle OAB. So our focus is this triangle OAB that we have. If the circumcenter of this triangle lies on the circle, अगर ये ट्रायंगल इंस्क्राइब्ड ट्रायंगल है, इसका सर्कम सेंटर ट्रायंगल पर होगा. सो यहां पर सर्कम सेंटर की प्रॉपर्टी होती है, वी हैव डिस्कस दिस इन द discussion on centers of triangles कि in center and centroid always lie inside the triangle, but circumcenter and orthocenter can lie outside the triangle and they too in obtuse angled triangles. तो ये OAB obtuse angled होना चाहिए, मतलब एंगल AOB should be more than 90 डिग्री फॉर श्योर, तभी उसका सर्कमसेंटर ट्राइंगल के बाहर होगा, क्योंकि सर्कमसेंटर सर्कल पर है जो कि ट्राइंगल के बाहर है. देन सेक्टर OAB फॉर्म्स व्हाट पोर्शन ऑफ द सर्कल इन इनडायरेक्टली, मतलब बेसिकली एंगल AOB निकालना है, फिर वो पोर्शन ऑफ सर्कल भी निकल जाएगा. जैसे अगर ये 1/4 होगा तो एंगल तो 90 डिग्री होगा, मतलब एंगल क्या होगा, अगर सेक्टर इज 1/4 ऑफ द सर्कल तो ये एंगल 90 डिग्री होगा, बट ये एंगल 90 डिग्री नहीं हो सकता, तो दिस ऑप्शन इज रूल्ड आउट. 3/8 होगा तो एंगल क्या होगा, 3/8 ऑफ 360, 360 by 8 is 45, 45 into 3 is 135. हाँ ये पॉसिबल है. 1/3 मीन्स 360 का 1/3 is 120 डिग्री, हाँ ये भी शायद हो सकता है. 5/12 ऑफ 360 डिग्री, 360 by 12 30, 30 into 5 150 डिग्री, शायद ये भी हो सकता है. तो ऑप्शंस तो तीनों मतलब हमें अब सॉल्व करना पड़ेगा, मतलब हम ऑप्शंस एलिमिनेट करके नहीं कर पा रहे हैं, तो करेंगे कैसे. टू डू सर्कमसेंटर होता क्या है, आपके बेसिक्स टेस्ट हो रहे हैं. सर्कमसेंटर इज द पॉइंट ऑफ इंटरसेक्शन ऑफ परपेंडिकुलर बाइसेक्टर्स ऑफ द साइड्स ऑफ अ ट्राइंगल. तो आप वो फिगर तो बनाओ सर्कमसेंटर की, परपेंडिकुलर बाइसेक्टर साइड्स की बनाओ तो सही, तब आपको दिखेगा कि ज्योमेट्री क्या हो रही है. ये OA का परपेंडिकुलर बाइसेक्टर बनाओ, कुछ होगा कुछ समथिंग लाइक दैट, और यहाँ पर कहीं ये सर्कल को जहां मीट करेगा वो सर्कमसेंटर है. और सेम वे OB का भी सेम चीज, वो भी यहाँ से ऐसे पास करना चाहिए, यहाँ पर ये सर्कल पर है, ठीक है. एंड ये मैं वो बना नहीं रहा हूँ, बट ये चलो बना लेता हूँ, ये वाला भी मैं बनाना नहीं चाह रहा हूँ, या बना ही लेते हैं, चलो कुछ नहीं. ये भी AB का भी परपेंडिकुलर बाइसेक्टर, वो तीनों यहाँ पर मीट कर रहे हैं. दिस इज C दी सर्कमसेंटर. ये मुझे ये एंगल चाहिए, क्लियरली फिगर में सिमेट्री है, तो ये एंगल तो बाइसेक्ट होगा ही, एंगल AOB होगा जो होगा वो OC के द्वारा बाइसेक्ट तो होगा ही, राइट. फिगर एकदम सिमेट्रिक है, तो मेरा ऑब्जेक्टिव है ये एंगल थीटा फाइंड कर लेना. मुझे पता है कि ये 90 डिग्री है, क्योंकि ये बाय कंस्ट्रक्शन ये परपेंडिकुलर बाइसेक्टर एंगल है, ये परपेंडिकुलर बाइसेक्टर है, तो ये 90 डिग्री है. मुझे थीटा फाइंड करना है. ये कुछ पॉइंट्स इसको मैं मार्क कर लेता हूँ, कुछ P और Q, ये जो पॉइंट्स हैं, जो मिड पॉइंट्स हैं OA और OB के, है ना. तो मिड पॉइंट्स है ना, क्योंकि परपेंडिकुलर बाइसेक्टर है, राइट. रिमेंबर सर्कमसेंटर किसका मीटिंग पॉइंट होता है, परपेंडिकुलर बाइसेक्टर्स ऑफ द साइड्स ऑफ द ट्रायंगल. सो माय पॉइंट इज आपका OP क्या है, हाफ ऑफ OA. OA क्या है, रेडियस, तो दिस इज r/2. व्हाट इज OC, रेडियस. ये 90 है, थीटा है, ये r/2 है, ये r है, तो ये बेस है, ये हाइपोटेन्यूज है, तो cos थीटा आपका क्या आ रहा है, r/2 अपॉन r, हाफ. आ दोगे आंसर. ये थीटा जो है क्या हो गया 60, तो पूरा क्या होगा, वो भी थीटा होगा. सेम चीज वहां पर भी है, ये भी r/2 है, वही चीज cos थीटा वहां पर भी हाफ है, तो आंसर क्या है 120 डिग्री, राइट. तो देखो कितना बढ़िया सवाल है, एक लाइन का सवाल था, लेकिन सारे बेसिक कंसेप्ट टेस्ट करके चला गया ये सवाल. ऑल राइट, सो वेल सर्कल्स में क्वेश्चंस देखो बहुत बनते हैं. आप अगर जितने भी एग्जाम्स में देखोगे ना, तो आई मीन सर्कल क्वेश्चन बहुत तरीके के होते हैं, बहुत कंसेप्चुअल होते हैं, क्योंकि आप अपने ट्राइंगल और क्वाड्रिलेटरल की पूरी ज्योमेट्री करने के बाद सर्कल्स तक आते हो, और फिर वहां तक आते आते आपके वो वाले कंसेप्ट भी आपको चल रहे होते हैं, साथ साथ में सर्कल की प्रॉपर्टी भी आ जाती हैं. तो मेरे ख्याल से एक क्लास थोड़ा सा मुझे लगता है कि जस्टिफिकेशन नहीं है, तो हम नेक्स्ट टाइम भी सर्कल्स पर ही मिलेंगे, ये मेरा आपसे वादा है कि सर्कल्स पर और भी क्वेश्चंस की वैरायटी हम देखेंगे. सो विद दैट I'll say thank you. I'll see you next time and keep up with the practice. Thank you. All the best.